Hey everyone, welcome back to Math 111. This is Scott, and let's get started. So let's talk now about section 5.4, where we take our old friends' polynomials and we divide them. Now this will be useful to us for two main reasons, one having to do with polynomials themselves, the other having to do with another kind of function we'll be looking at later called rational functions. But here's the basic idea. 2 polynomials can be divided in a similar way to the division of two numbers. So division is a thing that you can do with numbers, but you can also do it with polynomials, and we're going to look at how we can accomplish that and how we can use that. So first off, some notation and language. And here what we're just going to be exploring are what we call the various ingredients of a division. So if we write it in the standard American way, there's a number here, a number here, a number here, and then maybe a remainder over here. And the names for all of these are, this part is called the dividend. Oops, dividend. This part is called the divisor. Up here is called the quotient. And then there's a remainder, perhaps. So there's the dividend, the divisor, the quotient, and the remainder. And another way of writing this is dividend divided by divisor equals quotient with remainder. Alright, now specifically, if we have something like A divided by B equals C remainder D, then what this means, so this means that if we did A divided by B, the result would be C plus some little remainder, which is also divided by B. Or if we were to multiply everything by B, that would mean that A is equal to BC plus D, is what this would mean. Now, to see how we can actually accomplish this with polynomials, let's remind ourselves how this actually works with numbers. We'll start with something short and easy and work our way up a little bit. So, examples. With numbers. So let's just take as an example something like, let's say 2020, the current year, divided by 7. So the way this would work is so you would write 7 divided by, or sorry, 20 divided by 7. And what you would do, if you remember, is you look at this and you see whether it goes into 2. And if not, you see whether it goes into 20. And if so, you figure out how many times. So 7 times what is the maximum we can get without going over. It's Price is Right rules here. So we can do 2 7s before we exceed it. So then down here, we put a 14, and if you remember how that works is that's 7 times the 2 that we got up there. And then we subtract, and we would get the 6, and then down would come the next digit. And then you ask yourself again the same question. How many times does 7 go into this number down here, 62? Well, 7 times 9 is 63, so we can't quite go that far, but we can go almost. So we can do 8. Then you do 7 times 8. That number goes down here, so it's 56. Then you do the subtraction, and that leaves you with 6. And then down comes the 0. So you have a 60. And now you ask yourself the same old question again. So these are the various parts that are going into that. Then you ask yourself the same question again. How many times does 7 go into that number down there? And 7 times 8, as we just said, was 56. So that would be the most we can get here. So it'd be 8 again. So the third digit here will be the 56. You subtract as usual, got a 4, and that makes a remainder of 4. So what this means is that 2020 divided by 7 is equal to 288 remainder 4, or in other words, 2020 divided by 7 is equal to 288 plus 4 over 7. So those four were left over. We couldn't break them up into any more 7s, and so what we're left with is 4 odd parts out of a 7. There's 4 7s. There. So here what we have is the quotient and the remainder. This one is the divisor and the dividend. Okay. Now let's try an example. This was short division, or this was a single digit example. Now let's move to a couple digits. So let's just say something like 3157 divided by 15. So let's remember how this would work. So you go 15 goes into 3157, and you would just ask yourself, how many times does 15 go into 3? Well, none. How many times does 15 go into 31? Well, it goes in there twice. That's the first digit. So then 15 times that same 2 would equal 30, which would go right here, which we would then subtract, and that would leave 1, and that would leave and then we would bring down the 5, 15. How many times does 15 go into 15? Well, just once. And so then that's going to be 15 times 1, So it goes down here, 15. And so when you subtract, that's going to make it 0. And then you bring down the 7. And then what we have here is no, doesn't go in there at all. And then there's a, and so then that's 0, 7, and then that means there's a remainder of 7. So what that means is that 3157 divided by 15 is equal to 210 with a remainder of 7. Or in other words, 3157 divided by 15 is equal to 210 plus 7/15. Now, let's try looking at how this would work for polynomials. For polynomials, the setup is similar. So for polynomials, the setup is similar. You take the one polynomial, you put the other below, so you put the other to the left of it. So we have the dividend, we have the divisor, and we're going to be making the quotient, and we're going to have the remainder. But these are all going to be polynomials now. And the way we are going to build up the quotient is we will take the leading term of the divisor and the leading term of the dividend, and we will ask ourselves what we have to multiply by the divisor term to make the dividend term. So you make the terms of the quotient by finding the factors that you need to multiply the leading term of the divisor by to get the leading term of what's left of the dividend. Then what happens then is you do in a similar fashion to what we did with the numbers. You then multiply the divisor by that factor, subtract the result from the dividend, and then repeat on what's left over. So this is just a vague sketch, but we are going to, you'll see when we actually put it into play, it is very similar in setup to how it works with numbers. So for example, let's take something like this. Let's do 3x squared plus x minus 10 divided by x plus 1. Okay, so here's how this works. Here's how you set this up. 3x squared plus x minus 10 divided by x plus 1. Now all you look at is the leading term of the divisor and the dividend, and you just ask yourself, what do I multiply this by to make this? Well, to make an x into a 3x squared, what you need to multiply it by is a 3 and an x, and I'll put that on top of the x term over here. 3 and x. So this is what we looked at to produce that. Now this was what we multiplied by. So then 3x times x plus 1 is going to produce 3x squared plus 3x. So that is what we subtract then from the quotient. X squared plus 3x, and then we subtract that. Now, when you subtract a polynomial, you just have to remember that the negative gets distributed into both terms. So that's going to make a 0 here, and here it's going to be an x minus a 3x, so that's going to be minus 2x. And then we do like we did before, we bring down the next term. This is now effectively our dividend from now on. From now on, we are going off of this. So now we look at this again, and we look at this, and we figure out what will we need to multiply this by to get into that. Well, the most we can do is a negative 2. So we can multiply it by a negative 2. And if we do that, times the x plus 1, then what we'll have is negative 2x minus 2, which we then put here, but we subtract it, just like we subtract the number that we get in regular division. So ignore that 0, doesn't even come into play. Then this negative distributes, and so that's going to disappear, and then it's going to be 0, which we'll ignore, and then here the negative and a negative make positive, so it's negative 10 plus 2 is going to be negative 8. So it's a remainder of negative 8. So that means the quotient was 3x minus 2, remainder negative 8. Another way of wording this would be to say 3x squared plus x minus 10 all divided by x plus 1 is the same as 3x minus 2 plus negative 8 over x plus 1. So recap, how we produced this. So we put the dividend under the division, and then we put the divisor to the left of it. We looked at the leading term, we looked at the leading term. We figured out what are we going to have to multiply this by to make this. It's going to be 3x, so that goes up here. Now what do we do with that 3x? We multiply it by the x plus 1, and that produces this, which in turn goes up here, which in turn gets subtracted. And when that gets subtracted, all that's left is a negative 2x. Down will come the next term from up here, and then you repeat the process with this. So now the negative 2x, we look at that. What are we going to have to multiply by? It's going to have to be a negative 2. So then we multiply by that. And then we get that. And then we put it over here. And then we subtract it. Which means that all the terms become opposite. So that cancels. And this becomes a positive 2, which makes that a negative 8. And then that is our remainder. There's no more of that we can put into that. Once it gets below the degree of the divisor, then it's pure remainder. Alright, let's try this again with something that has a little bit more to it. So another example of this might be something like 3x to the 4th minus 2x cubed plus x squared plus 5 all divided by x minus 3. Now here, notice there's a missing term in this polynomial. There's no just x term. There's an x to the 4th, x to the 3rd, x squared, x to the 5th. Now in laying this out, it's convenient to include a space for the missing term. And you might space it out by even putting 0x plus 5. So this is to help keep the spacing proper. Very similar to the way the place values notation works for regular numbers. If it's like 301, you would still write the 0 in the tens place. And the reason is to help keep everything lined up properly. And we'll have an x minus 3 here. Now, you look at this, you look at that. You decide what you have to multiply it by in order to turn this into that. Well, it needs an x cubed and it needs a 3. So 3x cubed. And I put it over the x cubed column here. And then 3x cubed times x minus 3 is going to be 3x to the 4th, which matches that, just as it was designed to do, minus 9x cubed. And that's what goes over here. But remember, this negative will distribute to both of these pieces, so that really effectively is a plus. So that is a 0, no worries. Okay, now it all cancels out, and then over here we have plus 9x cubed, so that's going to make a total of 7x cubed. And then what we do is we bring down the next term in classic long division technique. So down comes the x squared, And then we repeat the process. So now we look at, what's left here. Shouldn't have done that. So now we look at what's left here, and we figure out what we have to multiply by this by in order to get that. So it needs a 7, and it needs 2 x's, so it's going to be plus 7x squared. And then we actually figure out what that will equal. So 7x squared times x minus 3 is going to be 7x cubed minus 21x squared. And that's what goes here, 7x cubed minus 21x squared. But it's all being subtracted, so we put a negative in front. And so these cancel each other. And that becomes a plus, which makes this actually 22x squared. Now, we bring down the next bit. And then we ask ourselves the same kind of question. We ask ourselves, what do I have to multiply the x by to get 22x squared? Well, it's going to have to be 22x. And so here, I figure out what would 22x times x minus 3 produce, and that's going to be 22x squared minus 66x. And that's what goes over here, 22x squared minus 66x, but it gets subtracted. And so the negative distributes, and what we get is 0, which we're not worried about. And then that becomes positive, so it becomes 66x. Down comes the 5. And then you just ask yourself one last time the question, what do I have to multiply this by to make that? And the answer is 66. And you only have to look at the first term for all of this, which makes it in some ways easier than long division with numbers. So then 66 times x minus 3 is equal to 66x minus 66 times 3 is so is that 198, I believe. Okay, and then that in turn goes over here, which we then have 66x minus 198. But it's subtracted, which means the negative gets distributed. And so that's going to be a 0 again. And over here we're going to have plus 198, which makes 203. So then a remainder of 203. Because there are no more x's, we've gotten to the end of our rope here. And so what that means is that the quotient was this, remainder this. Now let's look at one more example, and this is an example where the leading coefficient of the divisor is not just a 1. So now let's try for x squared minus 10x plus 3, all divided by quantity 4x plus 2. So now our coefficient on the x is not just a 1. So we've got 4x plus 2 and 4x squared minus 10x plus 3. Now we ask ourselves the same question. What do we have to multiply that by to make that? And the answer is, it's going to have to be just an x. So then x times 4x plus 2 will equal 4x squared plus 2x. That goes up here. But it is being subtracted. So we distribute the negative in, and that becomes the 0 that we ignore. And then the 10x minus 2x is going to be a negative 12x. Down comes the 3. And now we ask ourselves, what do I have to multiply that by to make that? And the answer is going to be minus 3. So it's going to be a negative 12, so negative 3 times 4x plus 2 is equal to negative 12x minus 6. And that's what goes over here. Negative 12x minus 6, which we then subtract, which then means the negative gets distributed in, which then means that the negative 6 becomes a positive 6, which then makes a 9, which gives us a remainder of 9. So that gives us a quotient of x minus 3 and a remainder of 9. Now this process, it works. It's okay once you get used to it. However, it's a bit tedious and it involves a lot of unnecessary writing. We can make a streamlined shortcut for it for certain specific cases, and that shortcut is called synthetic division. So shortcut. It's called synthetic division, and it can only be applied in a certain setup. So a certain setup, the divisor has to have the form x minus k. Then the layout. The layout here is you put the k above a little big L-shaped thing here, and what you put here will be the coefficients of the dividend. And that's including zeros if there are any missing terms. And then what's going to happen is down here is where the quotient will start to emerge. So the quotient coefficients will emerge down here, and they start at 1 degree lower than the dividend, starting with degree 1 lower than the dividend. So those go here, and then right here, what you're going to end up with in the bottom right corner this will be the remainder. And the way we build in these pieces is it's in the same vein as how you do long division. However, it's a little bit simplified. So what happens here is what you do. So this first term. So the first entry, just bring down leading coefficient of the dividend. And then what happens here is you make these little triangles by taking the previous quotient coefficient times k. And then the way you make the remaining entries down here, so these are entries after the first. The way you make those is you just add the square plus the triangle. Add the numbers above it. Okay, so this is just this is of course just a vague schematic layout. You won't be able to really know what's going on until the rubber meets the road and we have an actual example in play. So let's actually try this with a specific example. So as a specific example, let's take something like 2x squared minus x plus 3 divided by x minus 3. Alright, so the way this is going to work, we will, so here the k is equal to 3. So that means we're going to have a 3 right here in front of our big L shape. And then here, coefficient first is 2, then the coefficient is a negative 1, then the coefficient is a 3. Now the very first entry here, you just bring down the 2. So the very first entry just drops right immediately down. And then here, you do this times the 3, and that is how you get right there. So that goes right there. So the 2 times the 3, so times the k, gives you the 6. Then you add these. So negative 1 plus 6 is 5. So that is how you make this number. And then what happens next is you do 3 times 5 to make this number. that's this 3 times this 5. And then you do 3 plus 15, and that's how you get this number. And now our process is finished. This is the remainder. And these are the two coefficients for the quotient. So we'll have is 2x, so quotient. So just reading off the coefficients here, starting with degree 1 less than the dividend, 2x plus 5, and a remainder of 18. Now this may all seem like voodoo, and it may be suspicious to you. So for one time, let's just check this. So we can just check this by multiplying the quotient times the divisor. So x minus 3 times 2x plus 5 is equal to 2x squared plus 5x minus 6x, and then minus 6, or sorry, minus 15, let me say minus 15. And you'll notice that that means that x minus 3 times 2x plus 5, if I were to add the remainder of 18, gives me 2x squared minus x plus 3. Okay. So this is what it looks like when it all goes according to plan. There are a couple slight modifications we might have to make in different circumstances. So note, if the divisor is something like x plus 2, then k will be negative. And the reason is, it's supposed to be x minus k. And we fell short of that by having x plus something. So the k will be negative. And then if the divisor has a leading coefficient other than 1, we can divide both the dividend and divisor by that number to make the process work. Okay, let's try some examples of these. So now, for a couple examples of the kinds of things that can happen. Let's take, first off, something like 2x cubed minus 5x squared plus 2. all divided by, let's say, x plus 1. So first off, k here is not 1, it's negative 1. This was supposed to be a minus, it's a plus. So that's the first adjustment. And secondly, you'll notice that we are missing the x term. Like cube, square should be an x, and then a constant. So that means we're going to have a 0. So negative 1, and then we're going to have 2, negative 5. Here, there's a missing 0. And then a 2. Now the first term of the quotient comes. We just bring down the initial coefficient. Okay, so that gives us that. Now 2 times negative 1 equals negative 2. So that is what goes up here. And then we add those. So that's a negative 7. That goes there. We do negative 7. I should keep noting this. I'm not going to always write what exactly produced each thing, but because this is a new process, I want there to be in the record where each number in this came from. So we added the numbers above it to make the negative 7. Then we do the negative 7 times negative 1, so times the k. That equals 7. And that's what goes up here. And then we add those to get a 7. So 7 plus 0 equals 7. That's what goes right there. 7 times negative 1 is negative 7. That's what goes there. And then 2 plus negative 7 equals negative 5. That's what goes there. So that's the remainder, and the rest are the terms. So we have a quotient, and it starts with an x squared, one less degree than what the dividend started with. So it's going to be 2x squared minus 7x plus 7. And a remainder of negative 5. Okay, now let's have a look at what it would be like if we did have an extra coefficient in there. So let's say we have 6x cubed minus 2x squared plus x minus 1 divided by 3x plus 1. So in order to make this work, what we have to do is we have to divide everything by the 3. Divide all terms by 3. Okay, so then what we've actually got here is 2x cubed minus 2 over 3x squared plus 1/3 x minus 1/3 divided by x plus 1/3. So now it is of the correct form for synthetic division. So that means that k here is going to be negative 1/3, And so we're going to have negative 1/3, and then there's going to be the 2, there's going to be the negative 2/3, there's going to be the positive 1/3, there's going to be the negative 1/3 for the coefficients of the dividend. Then down comes the 2 in regular fashion. Then we do 2 times that, and we'll have negative 2/3. Then we add those, that'll be negative 4/3. Then we do this times this, and that'll be positive 4/9. Now I know some of the arithmetic might be going a little fast and furious for you, especially, but the whole point of this process is that it's supposed to be fast, and so here we're not writing down as much as we did before, because there's no point in doing a shortcut and then writing so much that it actually takes longer than the original method. Then we add these two together. So 1/3 is the same as 3/9 plus 4/9. It's going to add up to 7/9. Then we multiply them, and it's going to be negative 7/27. And then 1/3 is the same as 9/27. It's going to be 9/27 plus 7/27. So negative 16/27. Just for the record, the reason how we did this was it's the same as 3/9, and that's the same as 9/27. So we just multiply the top and bottom by 3 in this case, by 9 in this case. Okay, and then that gives us a final answer of a quotient. That is 2x squared minus 4/3 x plus 7/9, and the remainder negative 16/27. Alright, now so far all of the cases that we've seen have had remainders besides 0. What does it mean though if there is no remainder, if it divides evenly? So note, if a polynomial division, whether you do it with long division or synthetic division, should end up with the same result. If a polynomial division produces a remainder of 0, then the divisor was one of the factors of the dividend. So for example, let's take something like x cubed minus 8 divided by x minus 2. So here we can actually do the synthetic division if we want, or we can do it with long division if that's your cup of tea. In any case, so if I do it with the synthetic division, k is going to be 2, and in any case we're going to need to account for the missing terms here. So there's going to be 2, and then it's going to be a 1 for the first coefficient, 0 for the x squared, 0 for the x, and negative 8 for the constant. And then down here we pull down first just the first number there. Then we do 2 times that, and we put that up here. Then we add those, and we put that down there. And then we do 2 times that, and we put that up here. And then we add those, and we put that down there. And we do 2 times that, and we put that up here. And that, you'll notice, is going to give us a remainder of 0. So what this is going to give us is, so these are now x squareds, x's, 1's, and remainders. So it's going to give us a quotient of 1x squared plus 2x plus 4, and a remainder of 0. So what that means is x minus 2 times x squared plus 2x plus 4 is actually equal to x cubed minus 8. And if you were to multiply that out, it would all work out. Now, what this means is then that if we have no remainder, then anything that makes the divisor 0 would actually also be a 0 of the dividend. So then, where there is no remainder, any 0 of the divisor, is also a 0 of the dividend. And here by 0, again, we mean it in the sense that we meant it in the last section. So, i.e., where the divisor equals 0, the dividend will have an x-intercept. Now, what this actually means for us is that if I were given a graph and I were able to read off the an x-intercept, I could use that to actually figure out what polynomial it was, as long as I knew what other factors there were. So using this. So it will be given a graph and one factor of a polynomial. Then we'll use the graph to find the x-intercept and make another factor out of that. Then include an unknown coefficient and use another point from the graph to solve for its value. Alright, so now let's take as an example the following. So use the graph and given factor to find an equation for the polynomial. And the graph will look like this. So we'll have it go like so, like so, and we'll say that that is -1, and we'll be told a factor of x squared plus 2x plus 3 and then here we'll be told that this value is 3. Alright, so let's give this a try. So first off, based on this this 0 right here, we can already tell, I call this example A by the way, we can already tell that the 0 of x equals -1 would imply a factor of x plus 1 equals 0. So x plus 1 will be a factor. And note that this has the appearance of a multiplicity 1 factor 0, so we don't have to worry about there being an exponent or anything. So then, what that means is we're going to have the formula f of x is equal to x plus 1 times x squared plus 2x plus 3 with the mysterious coefficient of a. So this is our unknown coefficient. This is our unknown coefficient of a. Now what we use is the other point that was given to us, here the y-intercept, 0, 3, where 0 is the x, 3 is the y, to find the a. So 3 equals the mystery a times 0 plus 1 plus, or times 0 squared plus 2 times 0 plus 3. So that means 3 equals a times 3, or a equals 1. So that gives us f of x equals just 1 times x plus 1 times x squared plus 2x plus 3. Alright, let's try this one more time. This time with a coefficient that's not going to equal 1. So let's say that the graph that we have looks like this. So we'll have a 0 here of 3, and we'll say that there is a factor of x squared plus x plus 2. And then furthermore, let's say that right here what we have is the value of 12. So now it's up to us to figure out what the formula for the missing function must be. Well, so far everything is pretty normal. X equals 3, apparent multiplicity of 1, which means that x minus 3 equals 0 would produce x minus 3 as a factor. So x minus 3 is a factor of this. Okay, well then, that means that f of x is going to have the format some mystery coefficient times x minus 3 times x squared plus x plus 2. Now here we're going to be using again the y-intercept, which is 0, 12. Use the y-intercept whenever it's available, because for one thing it's the easiest point typically to read off, and for another thing it is a point where the x's are all 0, so that makes it easy to plug in. So 12 is equal to mystery a times negative 3 times 0 plus 0 plus 2, and that's going to mean that 12 is equal to negative 6a, which means a itself is going to equal negative 2, which gives us a function f of x is equal to negative 2 times x minus 3 times x squared plus x plus 2. Alright, well that's going to do it for this section and for this week. Join me next week for another episode of Math 111. The saga continues. I'll see you then. Bye.